Hello everyone. Welcome to the 24 hours of PES evolution of the data platform. We are really excited you could join us today and for the Silvia Doomra session about the Elastic Database Client Library and the Elastic Database Transactions. Thank you, Silvia, first of all. This is 24 hours of PES, so this event consists on 24 consecutive live webcasts delivered by the expert speakers from the PAS community. The sessions will be recorded and we will post it after the event. To access on any demand sessions, please visit the main website, that is www.24hoursofpes.com for all session links. We will be posting it like 1 week from today, okay? My name is André Batista. I will be your main moderator today, so I can handle the questions and so on. And I will just show you first introductory slides before I pass the word to Silvia. So about if you require any kind of technical assistance, please type your question in the question pane located on the right of your screen, and someone will assist you. This question pane is also where you may ask any questions through the presentation. Feel free to enter your questions at any time, and once we get to the question and answers portion of the session, I will read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on top of the presentation window. Also, please note that there will be a short evaluation at the end of the session. Since your feedback is really important for us, please just take 10 seconds to complete it. It's important just for the speaker and for the PAS and everyone, okay? This event is just possible because our amazing sponsors. So I would like to thank Microsoft, Amazon Web Services, Hortonworks, and Redgate. Also, I would like to thank our supporting sponsors, that is HP Enterprise, SQL Century, and Sandisk. Really, these kind of events and all the past ones, it's not possible if they are not supporting, since they are free of charge, and they just support the event in a generous way. Also, as you can see in this slide, make sure you explore everything else PAS has to offer for the data professionals. There's a lot to explore on the website. Also, you can join local user groups around the world, special interest groups, and find free online resources through our learning center, and read up on the latest community news in the Connector newsletter. So now I will present and Silvia will start speaking. Thank you once again, Silvia. You may start.
Thank you, Andre. Thank you so much. Hello, everyone. Thank you for joining and giving your precious time to us. Good morning, good evening, good afternoon, based on the time location you are in. Before I jump into the content, just a little bit about me. My name is Silvia, as you might have read until now. I currently am a program manager in Microsoft, and I work on Azure SQL Database team to build the scale-out technologies. I've been at Microsoft for last 8 years, and in these 8 years I've worked on different products, starting from Windows Server to Visual Studio to operating systems, and it's just a little over a year that I've joined SQL Azure team, where I've been working on the scale-out projects that I will be sharing with you tonight. And here are some social media contents that links that you can connect me with if you would like to. So let's get started with the content directly. So before I jump into the details of the technologies that are available, I would like to address the 3 key scenarios that we're targeting with the technologies I'll talk today. The first scenario we're targeting is developing an OLTP application with the scaled out data tier. Basically, what we have seen is that when you as an application developer or anybody who wants to develop an application, there is a business logic that's the reason behind you starting. So when you start developing the application, our key focus is to make sure that you are focusing more on the business logic of your application versus building the data layer underneath it. We have built technologies that take care of that automatically, so that you're more worried and you're more focused about the business logic than focusing on the data distribution management part of it. Once you have your application built out, the next scenario is basically scaling your application in and out dynamically. So once you have your application there, how do you make sure that your new customers are added to your application without doing much of manual work? Or if for any reason you have to shrink the capacity of your application, how do you do that dynamically as well through your application? And last but not the least, once you have that many databases in your application, how do you manage all of them? So let's jump into the general Tenancy models that we have seen while talking to our customers. When we interviewed our customers, there's certain set of patterns that we've seen in the data distribution. And this by means, what I'm showing on the screen is by no means the complete set of Tenancy models that are available. There are a lot many more of that. This is just an oversimplified view of it. So the simplest Tenancy model that's available in the market today is the single Tenancy model, which means basically you have one database that's assigned to a single tenant. Whenever you want to add an additional tenant to your data distribution, you add a new database for it. This is the most recommended model at this point in time in Azure SQL database. The simple reason being it provides better data isolation properties. It gives security for the data isolated in different databases. And with the addition of elastic pools in the Azure SQL database, you don't have the resource constraint. Essentially, you can put a bunch of databases in a group, and you will be charged for the sum of those databases, and you can do resource management using the pool. So even the cost factor is reduced quite a lot with the use of elastic pools. So single tenancy model is becoming more and more popular with the introduction of elastic pools. But there are certain applications for which having a single database assigned to one tenant is not always an economical model. It becomes too much an overhead for some applications. If that is the case, then the next model generally we've seen our customers going towards is a multi-tenancy model, where you have data for multiple tenants stored in a single database. This does pose a challenge for data isolation. However, we do have capabilities to counter that as well. You can implement role level security and other functionality, but you have to take care of that on top of it. Instead, if you do single tenancy model, then it's automatically taken care for you. Having said that, the last model that we have is a hybrid model, because sometimes it's not always one or the other. It's not always black or white. We've seen customers using hybrid model quite a lot, especially in the cases take an example of an application which is a free application. Till the time your customers are accessing the free platform, they are added to the multi-tenancy model. But the moment they start becoming a paying customer, they are given a database of their own, essentially, and they're moved to single tenant per database model. So basically, once you have defined what's the tenancy model that's appropriate for your application, the first challenge in building that application comes is how do you manage the membership of your databases? How do you manage which tenant's data is stored in which database? So we have built a bunch of capabilities, and I'll talk about them. But the first three capabilities that I'm going to talk about, and I'll let you know where I stopped that, are basically available in the form of Elastic Database client libraries. They're .NET libraries at this point in time. However, that's just a starting point for us. The reason we are .NET library is because we wanted to test the market, and we are working on building that functionality in other platforms as well. But at this point in time, you can test them through, use them in your .NET application itself. Having said that, those libraries are open sourced on GitHub, so if you want to make any improvements or if you want to look at the code and make a parallel library for your platform, you can always do that, and if you want to contribute to that for the general public good, feel free to do that as well. We do take contributions, and we are more than happy to take a look at your contribution as well, and if that seems reasonable, we would incorporate that into the public release of the libraries. So with that libraries, the first functionality what we've built is what we call the shard map management. What that does is basically it stores information about which database contains which tenant's information or which tenant's data. And you can store that information in multiple patterns. One of the pattern is range map. For example, you can define that hey, my tenant 1 to tenant 5's data will be stored in database 1, 6 to 7 will store in database 2, and 8 to 10 will store in database 3, and maybe 11 is big enough, I'll give it a database of its own. But till the time it's a continuous list of continuous values, you can assign range map to your databases. But there are times when you don't want to do that. You want to have random numbers picked up, or you define your own pattern. For example, let's say you want to define like my tenant 1, 5, and 7 will stay in database 1, and 2 will stay in database 2, and 3 and 10 will stay in database 3. You can use list shard map, basically, which lets you specify individual tenants that you want to store in a particular database. And one database can have multiple tenants, definitely, if that's the pattern you go with. On the screen, I've listed some of the sharding key types that we support at this point in time. And if you think that's not sufficient and you need some other sharding type as well, we are more than happy to take your feedback. And we'd love to understand your scenario. So once you have your data distribution defined, basically the next thing comes is how does your application connect to the right database and add data appropriately to the database that you want to store in, or even query data from the right database, basically. So we've built a second set of capability which is called the data dependent routing that lets you query the specific database that has the data for the tenant that you're looking for. For example, let's say you want to run this query, select start from customers, but you want the customer ID to be 104, and that information is stored, the information for customer ID 104 is stored in database 2. Then what it would do is your client application would connect to Shard Map Manager. We have APIs, I'll talk about that in the next slide. But the idea is that it will connect to the Shard Map Manager, get the information about what's the database where that information is stored, come back to the client application, and client application will directly be able to connect to that database. So to enable that, we've introduced a new API for it. Basically, if you look at this code, this is what the data dependent routing code looks like. And if you look at it closely, it's pretty much aligned with what the current SQL code looks like. It has a SQL connection, basically, that lets you make the connection. It has a typical SQL command that lets you store the command, and it has a SQL data reader that lets you execute that command. The only difference in this piece of code versus a typical SQL code is this API, which is Open Connection through Key. So basically what this API does is, this API takes an input parameter, the sharding key, and this is the key that lets the Shard Map Manager know that this is the key associated to which the database I'm looking for. So once you run this command, execute this command, it returns a SQL connection for the database that stores information about this sharding key. And then your application performs exactly the same way. The only thing is this SQL connection is now directly pointing to the database that has that information. I'll show that in the demo as well, but just for the sake of clarity, I stripped out that code and just put it separately for better understanding. Now, you might feel that, hey, making a connection to ShardMap Manager every time when you need information for the database where the data is stored might be problematic, might add performance issues. However, we have built in caching mechanisms which would reduce the performance impact, and I'll just show you how it works. Let's say you make an open connection for key API call, and here's your application, client application, where you make that call from, and you're looking for tenant ID 104 in the previous example. You check the sharding key in the cache, and at that point in time, the application cache is empty. And if you can see in my previous slide, there are three levels of caches we have available. We have the cache available in the client application. We have a cache in the Shard Map Manager, which is called Global Shard Map cache, and then we have a local Shard Map, which is basically the cache of those entries on the shard itself. So with this, once the application checks that its cache is empty, it creates a cache miss, and it goes to the Shard Map Manager to fetch that information. It fetches that information and then connects to that shard. However, there can be a scenario where by the time you fetch that information from the Shard Map Manager and you made the connection, there can be some changes in the case that you are making too many changes in your application. If that happens, then we make a stored procedure call, which is SP validate, that validates whether the cache information that I have is still valid or not. And if it is valid, it's fine. If it is not valid, if the validation fails, then the connection will fail. Otherwise, the connection will go through. And you can define that using this option, which is called validate option here. So you have an option to turn it on or turn it off. Now, once you have your shards, or I would say the databases set up where you're partitioning your data, you are able to add data to your individual databases. You're able to query data from your individual databases. The next thing comes is how do you query data across databases? Basically, we have this functionality called multi-shard query that lets you query all the individual databases participating in the partition and gives you a union all result of all the individual results. So this is, again, I'll show that in the demo as well, but for the sake of clarity, this is what the multi-shard query code looks like. And it's, again, similar structure as to the typical SQL code. You have, instead of a SQL connection, you have multi-shard connection. Instead of a SQL command, you have a multi-shard command, and instead of a SQL data reader, you have a multi-shard data reader. These objects are pretty much aligned with the existing objects in the SQL code. The only thing is they are designed to act on multiple databases at one point in time and give you a union all result. I think Angie will share the PDF file for this presentation, and in that I have the link to the documentation map, so you'll be able to get this once Angie shares that file with you. So let's see the demo right now. So all the capabilities that I've shown until now are available only in the form of client library. The next capabilities I'll talk about, they're available in the multiple forms, but this one is only through the .NET library at this point in time. And we would love to have your feedback if you have a requirement for other platforms as well. So here is the demo that I'm using. So I will show you, this is a publicly available sample that I have, that we have, and you can pretty much install it from, if you go to online samples and search for Elastic. So when you search for Elastic, there is the sample Elastic Database Tools for Azure SQL Getting Started Guide. This is the sample that I'm using at this point in time, and you can download it from your Visual Studio as well. And once the only change you would have to make once you download that sample is there would be a app config file that takes information about your server name and username and password for the server name that you want to connect to. So before I run this sample, I'll show you what this looks like in SSMS. So I have this server, I'll refresh it. And here I have 3 databases. At this point in time, I have just run this simple create database command. They're pretty much empty databases, nothing else done on these databases. And for the sake of this sample, I have created one database which will act as my shard map manager, and other 2 databases which will act as my shards, or you can say the databases that will participate in the data partitioning. When you use the online sample, you don't have to create these databases. I just created them ahead of time to save some time in the presentation. But once you run the sample, it will create the database for you. So let's just run that. So here is what it looks like when you run the sample. At this point in time, as you can say, it will say the shard map manager has not yet been created. So let's first go ahead and create that shard map manager. So basically what it is going to do is it is going to go to my shard map manager database and lay metadata on top of it that will recognize that this is the database that is going to store information about my individual databases. One thing to note for future reference is that it is given a name for the shard map manager which I'll use in my future demos. So for reference, it is customer ID shard map. You can name it whatever you want. So this is just a unique identifier for the shard map that you store in your shard map manager. And then once it has created laid metadata on top of my shard map manager, the next thing it has done is on the shard 0 that was there, it laid metadata on top of it to recognize that it is my shard, it is going to participate in the data partitioning, and it associated ranges 0 to 100 to that databases. Now this is hard-coded in the sample, but you can very well change it to your requirements and you can make it something different. And then it did the same thing with the shard 1. It prepared the shard 1 and associated ranges 100 to 200 with it. So once I've done that, the next thing is basically adding data into my shard map shards using data dependent routing API, which is open connection for key. So for that, I'll use option 3. So as you can see, it inserted a row in my table, in one of my tables. So for sake of this demo, let's enter multiple data entries into my different databases. And you can see the data entries that are getting added are different ranges, 120, above 100 as well, and below 100, because my demo is randomly picking up these numbers. So let's do a multi-shard query basically. This is exactly the code that I showed you, a multi-shard query. And what it is going to do is it is going to query all the shards and give me a union-OR result of all the queries. And as you can see, all the results from the from different shards are getting shown here. One thing to note is that I have an option to include the shard name where the data is fetched from to know where my data is coming from. And here it has listed that the first 3 entries have come from shard 1 and the last one has come from shard 0. And you can choose to show this column in your code and you can choose not to show this column as well. So you have an option in your code. So yeah, that is pretty much this demo. Moving on to the next set of functionalities we have. Basically, as I mentioned previously as well, the capabilities that I talked about previously are available in the .NET form, and any capability that I'm going to talk about next is available in different forms. For example, this capability that I'm going to talk about, it's called split merge, and it is available in the form of .NET library as well, and it is available in the form of portal as well. So you can drop a package into your subscription and use this functionality in your portal, Azure portal. So basically what this does is that consider a scenario where you have a database which is a multi-tenant database, and you have multiple tenants data stored in that database, and eventually as your business is growing, the data in that database grows out of capacity, and you want to now separate the databases, separate the data for different tenants into different databases. In that case, you would want to split your data into multiple databases from a single database, and you would use split functionality. But there are certain cases when you have multiple databases lying around and they're underutilized in their capacity, and you want to merge data from them. In that case, you can use the merge functionality to merge data from multiple databases into a single database, and you can use this functionality in the customer hosted Azure portal or through client libraries as well. Now, the next set of capabilities that we have is pretty similar to multi-shard query that I showed, but as I said, multi-shard query functionality it's a very important functionality, and that's available only in the form of .NET library. However, as DBAs, as lovers of T-SQL, we want to run our queries in T-SQL and want to have the same functionality. On top of that, there are a couple of tools available in the market, and I would say most of the tools available in the market that take a single database interface. So when you have a sharded setup like whatever you define, or which would look like this, which has thousands of databases, how do you configure your reporting services like Excel, Power BI, which takes just a single database input, to work with this distributed set of databases and make them look like just one database? So we have the capabilities called Elastic Query, and what that does is that gives you a single database interface on top of all your databases, so that you can use these tools, or you can use T-SQL to run your queries through SSMS on your set of databases. So let me show you a demo of that. So basically, this is the same databases that I have, my shard 0, shard 1, and shard map manager. And I have created this remote query database. Basically, what this remote query database is, I'll show you the definition of the database, and this is all what I've done is I've created a table in the remote query database by the name customer. I've inserted a couple of rows into it, and if I run this query, it shows me 8 rows. So I have 8 rows in this database. So, oh, sorry. Just stepping back. Forget about the remote query database. I'll talk about it in a minute. But let's use Elastic Datacamp database. This is my database, which is blank. And so I would use this database as a single interface over my sharded setup. Let's firstly do that, and then I'll jump into remote query. So what I've done is to enable that on ISV Datacamp database. What I need to do is, you need to create a password, you need to create credentials, and once you have your credentials created, you create an external data source. Basically, external data source is your entry point to your data bases. So basically, in this data source, I define that the type of my databases that I want to access is the shard map manager type databases. I give the location of my server, name of my server. I give the database name which I want to access, and since in the shard map manager setup where my data is distributed, shard map manager database is the database that knows that has information about my individual tenants and the keys it is stored. So I'll give the information about my shard map manager DB, the credentials that I just created that I used to access it, and the name of my shard map that I used in the beginning. So you would remember this is the name of the shard map that my application gave to the setup. So I've already done that. I've already created all this setup on my ISV Datacamp database. The next thing you need to do is create an external table. So consider external table as your view to your individual tables in shard 0, shard 1. So this table definition is exactly same as the definition of my table or my partitioned table in shard 0 and shard 1. So I define that table as an external table in my ISV Datacamp database, and then I give it the parameters of data source that I just created above, and I define the distribution as sharded, and this is my customer ID on which my data is sharded. So once I define that, I'll show you that I already have these created. Okay, let me just sorry. It was just working a minute ago. This is the demo. Oops. Why is it not working? Yeah, it was just working a minute ago, and I'm sorry. This looks like a demo fever that my machine has stopped working. So I'll try one more time, and if this works, yeah, it got connected. So should be okay. I'll increase the font size. So I'll show you the external tables I have. So here is the script that I used, and I created cross-DB query credentials. So in this, I created my cross-DB data source. So ignore the second one. I'll talk about that in my next demo. But this is the data source that I created, and customer was the table that I created, external table that I created in DataCamp. So when I run this query, select start from customer, basically let the result show up. But the first query, you'll notice that that you run using this setup is generally a slow one because it's loading all the DLLs and doing all the groundwork. But once you've run the query once, it works perfectly fine, and it doesn't take any time to fetch data once that connection is established and your DLLs are loaded. Okay, so it's back because I had added 4 data rows into my shards. It has given me 4 data rows. Now let's go back to this application that I was running, and let's execute an addition of another row into my shard. So now I've added another row, and if I do select star again, it is showing me updated results. So you can notice that once I did my setup of creating external data source and external tables, I don't have to do pretty much anything. After that, whenever the data is updated, my queries fetch the updated results. So I don't have to change my setup every time or update anything in my single database that is used for getting view of my from my application. I don't need to change anything in this. Everything works fine. All my queries work fine. Now, going back to this image that I just showed here, if we oversimplify this and we take the sharded setup out of the picture, basically what this functionality gives is the most requested feature in Azure SQL DB, which is called cross-database queries. So let me show you. This is where the remote query table comes in, database comes into picture. So let's assume I have this remote query database, and this is the setup that I did. I created a table in it and added some rows in it. So when I do that, select start from this table, customer table, I have 8 rows in it, and I have done a remote query that is a local query on this database. So for fetching the results from ISV data camp, the results of remote query database to ISV data camp, I have to follow exactly the similar guidelines that I did in my previous setup. The only difference is that in this case, when I would define the same the credentials the same way. In this case, when I define my external data source, instead of a sharded one, I need to define it as RDBMS. This tells me that this is a remote database that has remote information that I want to connect to, and give information about the server and the database that I want to connect to with the credentials that I just created. And then I use the same method to create my external table with the same definition, with the data source information that I just created. And if I run this as well, and hopefully this connects, as you can see, I have my cross-DB data source as well created for you. So when I do query this customers, you can see I have 8 rows there, which I saw in the remote query database as well. Now let's go into remote query database, and insert a row into it. So now when I go back to my ISV data camp, I inserted that row, as you can see, in remote query database. Now if I come back to my ISV data camp database and query for the select star for that table, it will show me the updated results. So I didn't have to do any setup again to get the updated results. So getting back to the query, we just covered the demo of it. Now, you remember in the initial slide where I said there are 3 scenarios. The first is building an application using the scaled up data tier. That was the client library part that I showed with you. The second is basically scaling in and out your databases. You can use split merge to scale in and out of your database tiers that you have. And the last part is managing your set of databases. Once you have thousands of databases, how do you manage that? Even not thousands, the moment you get to a scale of 10 plus, management of databases become a little cumbersome because you have to run multiple operations multiple times on each database. So to simplify that scenario, we have created a new set of capabilities which are called Elastic Database Jobs. What that does is that gives you an ability to run a set of T-SQL statements on the set of databases that you define. Now this set of databases that you define using Elastic Jobs can be anything. It can be a sharded setup. You can choose to just use some random set of databases that are not associated with each other by any way. You can choose to use databases in a pool. You can choose to pick any databases that you want. You can choose to pick databases from a single server or use the sharded setup or whatever. So it's not dependent on the type of the collection of databases. Whatever data collection you have, you can run your T-SQL scripts on top of all your databases that you define as your target group. So the key scenarios that we've seen people using Elastic Jobs is basically, first of all, making changes to their databases, like managing maintaining the indexes, managing permissions on your databases, updating permissions, updating schema, and updating stored procedures, deploying new stored procedures, those kind of tasks. Whatever tasks you can do through just simply running T-SQL statements, you can just use that. And the second category of tasks that we've seen people use with Elastic Jobs is collecting results from many databases. Either you're collecting DMVs of performances from your databases, or you're gathering application-specific APIs. You can use jobs for that. Some of the key features is that you need to have a T-SQL script that you can execute on set of databases. It can be ad hoc. You can define that here, run it right now. Or you can schedule to execute that T-SQL script on the set of databases. And if you choose to run your T-SQL script on the set of databases ad hoc in an ad hoc manner, that is, you can say just run it right now, then it's a parallel execution. It's not a sequential execution. So in a way, it saves you a lot of time that it starts parallel executing that T-SQL script on all your databases in a parallel manner, asynchronous manner. And you can pretty much monitor the progress of your job execution. It gives you a very nice view of what are the databases that your T-SQL script has run on, what are the databases it has passed on, what are the databases it has failed on, and if it has failed, what is the error log for that. And it has an inbuilt failure retry mechanism that you can leverage. And as I mentioned, that you really don't have to constrain yourself to one specific group of databases. You can use this functionality on top of any set of databases you define, be it pools, sharded set, or all databases in one server, or any ad hoc collection that you just define. And you can use stored secure credentials as well with it. Now let's get to the last functionality for this last capability for this session. So basically, you might have used transactions in the on-prem world where you define a bunch of T-SQL statements and you want to execute them as part of statements. That gives the asset properties. But if you've executed them on-prem, you must be aware that you need to have MSTTC to execute those statements. Now, with the .NET Framework 4.6.1, we've introduced the capability of running transactions on Azure SQL databases as well. Now, since I said it's 4.6, .NET Framework 4.6.1, the reason I said that is because currently this capability is only available through .NET Library, System.Transactions. We haven't enabled that on the T-SQL side. However, we do plan to support it in the future. I don't have a timeline yet, but eventually it will come on the T-SQL side as well. So to enable that elastic transactions on top of the Azure SQL databases, this is what it looks like in the picture. And you can notice there is no MSDTC because there is no MSDTC on the Azure side. So the question comes is, how do you coordinate the transactions? Who takes on the role of MSDTC? So basically, the moment what happens is the moment your application that is working with .NET Framework 4.6.1, the reason I say it again and again 4.6.1 is that we've seen so many customers try it with .NET 4.6.1 lower versions than that, and it fails. It won't work for any .NET Framework before that. So you have to have 4.6.1 or higher. So once your application realizes that, hey, this is an Azure SQL database and this is a transaction that involves multiple databases, then it automatically elevates one of the SQL database that is participating in the transaction to the coordinator role. And that database acts as a coordinator for coordinating the transaction across databases that are participating in that transaction. So let's directly jump into demo. It's a pretty simple demo. So with the same code, and this is the demo that I'm showing right now is not currently available in the sample that I've shared, the sample that I've picked from the gallery. I've put that as separately in my sample, but I'll show you the code what it looks like. So let's execute that command to insert multiple rows as a transaction. So this is what my function looks like. In this function, what I'm doing is I'm creating a transaction scope here in the beginning of my function, and I'm executing. This code is pretty much my data-dependent routing code. I have just created these. This is my function that has the data-dependent routing code I showed, and what I'm doing is I'm just executing that statement twice in a loop. And I'm running that as part of transaction, and once that is done for twice, I've added 2 data entries, I complete that transaction. And as you can see, if you've written code for transactions in on-prem side as well, you would notice that these commands are carried over from the on-prem world. So whatever was supported on the on-prem is going to be supported here as well. So there is no code change. So pretty much you can pick your code from on-prem for transactions and port it here. All this, the commands or APIs that were supported in system.transactions for on-prem side will be supported here as well. And if you see something is not supported or something is not working, feel free to contact us. We would love to get that feedback. That should be a bug. That shouldn't be the case. So getting back here, if I execute it, if I continue that, it just added 2 rows into the system and it finished the transaction for me. So that's the simplest version of it. So the code remains the same. You don't have to make any changes. And again, I've just shown the same code. The code that I incorporated in the demo was the shard setup, shard specific code. But if you look at regular SQL code, let's say I'm making it to different databases and running some commands on top of it, you can do this as well. But the key part is the transaction scope, where how you begin the transaction and how you complete the transaction, and the APIs you use is going to remain the same. That's not going to change. We do support all the current DMVs that are supported for transactions on the Elastic transaction side as well. So there is complete parity in the DMVs. So that is pretty much what I had to cover. So just to recap what we talked about, I know we talked about a lot of functionalities, but just to recap, from the client side perspective, we have Shard Map Manager that acts as a catalog of your databases that are participating in the partitioning, and that stores information about which tenant's data is stored in which database. We have data-dependent routing that gives you a mechanism to insert data into appropriate databases. And then we have multi-shard query that lets you query across your databases and gives you a union or result of all the individual queries. And the above three functionalities are part of Elastic Database client libraries that are available on the NuGet as well. They're open sourced. And then last but not least, we have Elastic Database Transactions, which are supported as part of System.Transactions DLL. And then on the management services side, we have database jobs that asynchronously run a set of T-SQL statements on the set of databases that you define. And we have a split merge, which lets you split and merge data from different databases to a single database or from one database to multiple databases. And from the T-SQL front, we have the capability of Elastic Query that lets you query the distributed set of your data using a single database interface and lets you take advantage of the BI tools or reporting tools, and lets you do the cross database query as well if you have one single database as a target database. From the roadmap perspective, or where we are with these technologies, for the client library that I shared with you, that is generally available at this point in time, and as I mentioned, that is currently open sourced on GitHub. I have the link available, so if you want to check out the code, feel free to do so. We have jobs. So jobs are currently in preview at this point in time. And then we have Elastic Query that is again in preview. And then we have Elastic Transactions, and transactions are also generally available, so fully supported by Microsoft. Feel free to try them out, and if you have any issues or concerns, feel free to reach out to us. So yeah, that was pretty much it. We still have 15 minutes, so any questions? Andre, I can take up any questions if you have.
Yeah, thank you, Silvia. Currently, right now, there are not any questions, but well, we win some time with the attendees, I will make you one question. Tell me one thing, how this works with the database backups? There's any special stuff we need to do or take care about to have the 2 or 3 databases like in a consistent state in the time?
Sorry, I didn't understand. How does this work with? Can you repeat the
database backups. Database backups.
I didn't catch you, Andre.
Yeah, sorry. You can make it.
Okay. Sorry. Backups, right?
Yes. Yes.
Yeah. So basically, for database backups, you have to implement your own backups. So, for example, in the shard map manager, if you have your sharded set up with the shard map manager and shards defined, you have to create your own backup. Now you need to be aware that when you create that backup, your shard map manager with the entries would still point to the primary shards. That won't point to your backup shards. So your backups would still have the data, but they won't be pointed by the backup shard map manager. That you have to do it on your own. However, we do have APIs that lets you do that. So if you want to implement in your application that, for example, if you renamed your databases or you picked up the backup and you used it as primary and you want to update your entries in the shard map manager, you want to resolve conflicts, we do have APIs for that. But that's something you have to implement in your application and explicitly specify that, hey, this is my backup and I want to resolve a conflict. You don't have to do the manual task of resolving it yourself. We'll do that for you, but you have to tell us that, hey, you want to resolve that. So.
Yes, okay. Great. I was waiting for someone to have questions. I still don't see any question. Okay. Ellen just done us a new question that she's asking basically if there's anything that right now is not supported, like query ints, joins, and stuff like that.
Not supported in any specific functionality, are you asking?
Ellen is not stating that. She's just asking if you can do any kind of ints or query ints and joins and all those kind of stuff.
You can do pretty much what you can do in T-SQL with these technologies. So this is so for the shard. I'll talk about different functionalities. Thinking about shard map manager, it's pretty much an interface for you to run queries. So if you have T-SQL queries that can using well, let me step back. So if you have queries that run on a single database, these are just interface for you to run those queries, and you can pretty much do that. For joins, it is going to be a cross database query, And cross database query, you would be able to do that, but the syntax would change from the on-prem world. For example, in the on-prem world, you could pretty much do the join of the queries, right, with different databases. However, in Azure SQL database, by default, until like 2 months ago, cross-database queries were not supported. So with the ability of Elastic Query, you can do cross-database query, but your syntax changes. You have to create external data source, have to create external table, and then associate the credentials or data source that you create with your external table, and then run queries. So you won't be able to use 3-part name or 4-part name that you could use in the on-prem side, but you can achieve the same functionality with the Elastic Query. If you have any specific need that you want to specifically use 3-part name and 4-part name only, we would love to hear your feedback, because until now we haven't really heard a case where we have customers coming and saying they definitely want 3-part and 4-part name, they can't work without Elastic Query. So that should resolve all the concerns on the remote queries side. I hope that answers the question, and would love to hear your feedback if you think you need more information.
Yeah, Ellen, please, if it got answered, just say okay or not, and if you have any other questions, just please. And now, Silvia, I have another question from Phil Elmer that is basically asking how does foreign key support works. So imagine you have both tables, they have to be shared on the same key, or can be the foreign key be validated across the sharded ones?
Can the foreign key be validated the shard ones?
Across shards, yes. So if you use a foreign key, how does a foreign key support works in this architecture?
Actually, I'm not pretty sure about that. So basically, you can define your foreign key as the sharded key that will shard your data, that will partition your data according to the shards. And I'm thinking technically what from the implementation perspective would happen, but I would get back to you on exactly checking with my team if that's the correct behavior. But from what my understanding is, it would be that it can partition the data, and the sharded setup that you define, it's a pretty loosely coupled mapping, you can say. So you can define that, hey, my database 1 would store keys, let's say whatever the foreign key you're using, 1 to 100 information, and database 2 would have 101 to 200. But there's nothing stopping you from adding, let's say, tenet ID 78's information in database 2. There's no check that's available there that will stop you apart from the native foreign key functionalities in Azure SQL DB that would let you see, stop that, hey, you can't add that data there. So this sharding mechanism is very loosely coupled. It just gives you the mapping, but if you want to add incorrect data, there's nothing stopping you from that. But I'll get back to you on this after trying it out with my team as well.
Okay. Now, thank you, Phil, for the question. I hope that Silvia has answered you. About Ellen, she is asking right now, how about the MES DTC? Is there any performance improvement that you can tell us?
Sorry, can you please repeat the question?
Yes, about MES DTC, the Microsoft Distributed Transaction Coordinator, if there is any kind of performance improvement that you can share with us.
Performance improvement. So basically, you can definitely consider that in the on-prem world, you had to go to MSDTC to coordinate the transaction. You are with the Elastic Query, you're reducing the one hop that you had to make to MSDTC because there's no MSDTC, and your database is coordinating the transaction. You will get that much gain, but overall, it would be on par with the on-prem side, apart from that functionality. So performance shouldn't be a big concern unless and until your hop is not considered out.
Okay, Ellen, I hope this has answered your questions. If anyone else have any other questions, just please write. Okay, Ellen, thank you. Thank you for the explanation, Silvia. Ellen said that she did understand. Okay. I'm waiting for some more questions. I think there will be no more questions for now, Silvia. Of course, the people can reach you on email and your contacts and so on, right?
Sure, sounds good. Absolutely. Feel free to send me an email, and we would love to hear your feedback. If you have any questions, any concerns, or if there is something that you feel that's totally missing and you want to be included into the functionality, please give us feedback, and we would love to hear from you and your use cases. Thank you so much for your time.
Okay, Silvia. Can you just place the next slide, please? Okay, for the people that is tuning in right now, make sure you stay tuned for the next session, that it's about column sort indexes and operation analytics with Martin Cachiro. And once again, thank you everyone for attending this session. Thank you once again, Silvia, for your time. It was a great session. I really loved it. And please follow us on Twitter with the handle PES24Opt or with the hashtag 24Opt. I hope you have a great rest of the day, and I hope, and everyone else, hope here in PES that you enjoy the rest of the sessions. Thank you once again, Silvia.
Thank you, André.